Hey everyone. So for our project, we're analyzing a global consulting firm's organizational characteristics. Here's our agenda. We'll do some preliminary analysis and then look at more in-depth analysis using an ALAM and ERGM model. So our data set is an advice network from a consulting company. And the ties between each node are ranked from 0 to 5 for frequency of advice requests and the value placed on the information received. There are 46 total employees, and each of those employees have 4 attributes: gender, location, organizational level, and region. The questions we want to answer are all pretty broad, and we'll get more into them as we go through our analysis. But the first one is, how does gender play a role in this organization? The second one is, can we use descriptive factors to help predict cultural differences between offices, tenure or organizational level of employees? Can we also use those same factors to determine who the important people in this network are and what tasks they can achieve? And then lastly, can we predict the emergence of relationships in this network?
So here's just a general overview of the network. Like Andrew said, it's an advice network. Blue represents men, red represents women, and there are 855 edges and 350 mutual ties across the 46 employees. And as you can see, there are many outgoing ties between people of the same sex, same location, and same region, as well as gender. So using R, we were able to rank 9 local properties, 9 centrality measures. We were able to rank all of the nodes highest to lowest for all of these measures, and then do some analysis based on that. So from these outcomes, using the top 5, looking at the top 5 nodes for each centrality measure, we found that those with high in-degree centrality, who were those who were being asked for advice very frequently, were most likely to have high organizational levels. And we found the opposite to be true. Those with high out-degree centrality, those frequently reaching out for advice, or those with lower organizational levels, which makes sense logically, as this more senior members would have more knowledge about the company. Additionally, the top 5 advice givers were all men, and we found that those who gave out advice also had a high level of influence through their hub score and their authority score, which further makes sense with their high organizational level. And lastly, those who served as bridges and brokers between the 2 regions of North America and Europe all tended to work in the Boston and Paris offices, which was interesting.
So the first global property analysis is a K-core decomposition. A K-core is a subgrouping of all nodes directly connected to at least K other group members, which allows insight into social cohesion. The maximum level of cores in this network is 28 with 24 members, indicating high cohesion. Next, we rank community detection. Modularity scores quantify the division of a network into modules/communities. High modularity implies that more edges lie within a community than expected. This network has a modularity score of 0.095, which is positive but not super high, meaning that there's only slightly more grouping than expected by random chance. The plot also shows a high degree of overlap between the 17 detected clusters. However, there are 2 fairly distinct central clusters which might reflect a tendency towards mutual ties and location homophily that we find in the ERGM model. So this slide shows both in and out degree distributions in their log plots. Both decay fast and show significant differences from power laws. Okay, so these histograms represent the distributions of average path length and clustering coefficients for 1,000 randomly simulated similar networks. Our network has significantly greater clustering and longer path length than expected. So just to sum up, the global properties suggest that employees are able to collaborate effectively. The network is highly cohesive, and there's a narrow distribution of centralities. Essentially, all of these individuals are well connected.
So next, we use an autologistic actor attribute model to answer the questions that we have listed here. As you can see, all of these are somehow related to gender because that's what we set as our outcome variable. So we have questions like, those who report more connections, are they more likely to be men? So we actually tested that using this model. These are the results. So these are the different variables that we tested for. The ones that are starred on the far right are the only ones that were statistically significant. So the model did not do a great job of accurately predicting these. And because of that, we were kind of limited with our takeaways. But nonetheless, we did learn that those who report going to each other for advice are more likely to be men. And those who go to many different people for advice and are seeked out for advice by many different people are also more likely to be men. Lastly, because our model was not as accurate, that could mean that basically there's good gender dispersion across organizational levels and office locations. If that was the case, then the model would have a hard time predicting, because there's not as much of a stark contrast between who's likely to be a man and who's likely to be a woman.
With our ergo model, we had 5 main questions that were driving our analysis. The first one talked about mutual connections. Are those who are requested for advice likely to go to the person that requested them for advice? Next, we talked about the organizational level. Is being at a high organizational level mean that you're going to get more advice requests? Next, we talked about the organizational level. Are people who are on the same level likely to be able to talk to each other? Next, we're looking at the homophily with employees at the same location. And finally, we're looking at preferential attachment of employees at the same level of in degree and out degree. Are they talking to each other more? And so here are results. As you can see, many of these factors are statistically significant, which means that our model is most likely fit very well. And we'll go into a little bit more detail about what these results mean in the next couple slides.
So our ergo model did fit well. Our goodness of fit and all of our parameters were falling within the 95% tolerance interval, and we're close to the observed values. So the takeaways that we got from the hypotheses that we were looking at were, first, that people who are advice givers are likely to go to the people that they ask for advice, around 4.8 times more likely. There's also a large disparity between people in the lower level company position are more likely to ask for advice, whereas people who are higher in the company are less likely to ask advice. But instead of partners, who are the highest, is actually senior consultants, tier 3, who are most likely to be approached for advice. So for number 3, people who are within the same organizational level, so partners talking to partners or research assistants talking to each other, are not more likely to talk to each other than random chance. But those who work at the same location are, and they're about 5.7 times more likely. And one of the most interesting things we found was that people who are highly requested for advice all talk to each other, and people who give advice also all talk to each other. So there is high preferential attachment for who talks to who. Thank you.